Hello viewers and welcome to another STM32 World video. Um, I'm an idiot and there's no other way around it. Let me explain. Some days ago I posted the video with a crazy mystery, and the mystery was essentially I was trying to bitbang pulse width modulation, and it worked perfectly on an STM32F411, but failed on my STM32F405, which I'm using in the STM32 World Board. Strangely enough, as you can see from that piece of the source code, if I used bit banding, it appeared to work. And I was so focused on the fact that bit banding, this little bit here, worked, but if I used the BSRR register, it didn't work. Let me recap it and try it. So we have it here, which is the one that should be working. So let's try to run this one. And let me show the device, and I hooked up an oscilloscope. And you can see the LED in the lower right hand corner. It's a little hard to see because there's a bright green LED next to it, but you can see the pulses and the PWM working as it is supposed to. However, if we change and don't use this one and instead use that one, which should work as well, we can see that nothing happens. It goes high and it stays high, and that is about it. Now, I posted this on Facebook and I posted it on Twitter and I posted it on Reddit, and strangely enough, only on Reddit. I posted it in the STM32F4 group, and a smart guy saw the problem immediately. I don't know how he did it, because it had escaped me for a long time. So I guess I'm an idiot and he was quite smart. But the question down here, and lastly he says, let PWM CNC seems to be a 32-bit value. Let me go back and look at the, oops, sorry, I had that. So Jesus, I posted it, and he writes that let PWM seems to be a 32-bit value. So let's go back and look at the source code, and it's defined up here, and correct, it is defined as a 32-bit value. If we change this to 8, as it was intended, I even wrote that in the source code comment here. But if we just change that to an 8-bit value, which is what it was supposed to be in the first place, and look at that, and we see it works perfectly. So, in other words, it had nothing to do with the BSSR register or bit banding, and it works perfectly with the BSSR. Now, you may ask, why did this work? Why did the old one work with the bit banding? Well, notice that I'm casting in here. It's easier to see if I do that. I am casting the LED PWM count to 8-bit. Not sure why I did that. It was a while back, but it works now. If you set it as an 8-bit, or we can actually try to verify that. Let's try. Now, if we go back to the 32-bit value up here, there, and we try to execute that, it works as intended. But if we remove the cast down here, it will stop working and it will behave exactly like it did down with it goes high and it stays high. Now, if I go up and do the fix of this and turn this into what it was supposed to be, which is an 8-bit value, and run that, you will see that it runs perfectly without the cost. So that's pretty much it. I had a feeling, and that was part of the reason why I posted the video, that it was something glaringly obvious and very, very simple that went wrong, and I couldn't get my head around that the BSRR register in one MCU would behave different than it would in another one, largely in the same series of microcontrollers, 411 versus 405. But it looked like that, and it didn't occur to me that the problem was completely something else. So that's about it. I'm an idiot, and thank you so much to the guy that reached out to me on Reddit. Have a wonderful rest of the day.